I'm gonna join test series.
Okay.
Next week, part 11 physics, the test syllabus, sir. But still, we haven't completed gravitation and system of particles.
No, you're joined or you're going to join?
I'm going to join.
Okay.
It's starting from next week. Okay. Right, sir.
Okay, so that test is.
Okay, fine. I will follow the old block strategy.
Progress is there. So the test is on full syllabus or part syllabus?
Like class 11, class 12, and then whole.
Okay.
Whole class 11 and class 2.
Okay, then you have to study on your own because whatever you know.
Okay.
So when is the first test?
Next week after Thursday, sir, I guess so.
So how many? What is the total number of tests?
Total number of tests, I don't know, but if I have a test today, means then day after tomorrow I will have another test, sir, likewise.
So totally
1 day gap will be there. Till 15th July, they'll have tests.
Okay. Then it's okay.
So shall we discuss those test questions after every test?
Yeah.
Then it will be.
Yeah.
Okay, sir. That's what I wanted to convey.
Yeah, but fine. You should have covered everything on before itself. Fine, doesn't matter. So, but test is on July 15th. Has it been confirmed or?
Yes, sir. It is official notice only. Authentic information.
Okay, fine. Okay,
July
so
17th. NEET.
Okay, your exam timing is out.
2 to 5:20.
Okay, so what are you doing at 2 to 5:20 then every day? You should be studying for 3 hours continuously.
Yes, sir. Once I join this test series, I'll be accustomed to it, sir.
No. Start now itself. What's the problem? If you're able to sit for 1 hour, 2 hours means make it 2.5 hours. If you're able to sit for 1 hour, make it 1.5. Start from now itself. It won't happen.
Okay, sir. I'll try to.
If you're taking a nap, you just take it about 12 or 1. Okay. So you should be ready from 2 to 5. 2 to 5 you should be peaking. And it won't happen suddenly. Start from tomorrow itself. So step by step, slowly. Whatever you're doing, you just reduce it and then progress in the positive direction. Okay. So we'll start this chapter because other things are not.
The fluid. We have completed solid.
Fluid, they placed somewhere below, no?
And for fluids, I want from basics, sir. I didn't even touch that chapter last year. I left that chapter. Next fluid.
Not okay. I'll cover it after this one. Okay. Here, this is solids. See that? From this to this here. I'll do. No problem. So these are the different types of motion. So repetitive motion, example of repetitive motion is a projectile motion. And what is an example of repetitive motion? Example. Your mic is off.
Pendulum.
Yeah, simple pendulum. So uniform circular motion of planet going around the sun. Also, Earth revolving around its axis. That's why we have exactly 24 hours in a day, because it's a periodic motion. And that's oscillating motion of a simple pendulum. So concepts of period, frequency, displacement, amplitude, phase of this motion. So only when the thing is periodic motion or oscillating motion, we have concept of period and all, because projectile motion we don't talk about period because there is nothing like repetition. So when you have a repetitive motion, we talk about period. Okay, so what is this frequency? Okay, this
1
is
by T.
yeah, it's a time period, time variation. Basically, related to the time periodicity. Okay, time periodicity is what? The time period capital T. Okay, and reciprocal of the time periodicity is the frequency. When you're studying waves, what is the difference between waves in this SHM?
Force is directly proportional to the depth.
No.
The displacement.
In terms of frequency, the wave will also have a frequency.
Sorry, what?
The system has got a frequency, right? SHM will have a time period and the frequency.
What do you mean by simple harmonic motion, sir? Means that repetitive motion or periodic motion?
Simple harmonic motion is a special type of periodic motion. Okay, fine. Then I'll go through this one. I thought you already know. Fine. So simple harmonic motion. You know what is simple harmonic motion?
Oh.
You not studied earlier? It's there for boards also, no?
Yes, sir. I forgot it now.
Okay, fine. Periodic motion means it's repeating, and simple periodic motion means simple harmonic motion is a special kind of motion. In addition to repeating, the force should be proportional to the displacement. Okay, and the direction of the force should be towards the equilibrium position.
Yes, sir.
Okay. So instead climbing and falling down, and it repeats. So this is an example of a periodic motion. Okay. Yeah. It is climbing up, and it is falling down, falling down. So after it falls down, it doesn't keep quiet. It again tries to climb up. Okay. So this is a periodic motion. I think this.
But we can say that no, sir. It will cover equal distance in equal time.
Which one?
The insect. The insect. Randomly.
Falling will be falling faster. This is to follow the gravity, right? Climbing up, it will fall. It will take more time.
So your voice is not clear.
The background noise is there.
But your voice is not clear. Put on phone.
Okay, is it okay now?
Yes, sir. Volume is correct only, but your voice is not clear.
Right. So that's what I'm saying. See, while going up, it's going to crawl. While coming down, it just has to drop down. Okay, actually, this should be much steeper. Okay, so it will not be same time for going up and coming down, because the way it's going up and coming down is different.
Yes, sir.
Okay, then this is a ball bouncing up and down. here the time should be same. Okay. But wait, let's not get into the details. Basically, it's a periodic motion. Okay. So simple harmonic motion in addition to periodic, the force is proportional to the displaced distance from the mean position. Like from the mean position, just a minute.
Mean position means, sir, this is.
Oh, hold on. So, for example, if you take this spring oscillating, just a minute. Okay. So, for example, this simple pendulum. So it's like this. So it's oscillating this way and then coming back, right? So what is the mean position here?
That center point.
Yeah, this is the mean position. Okay, so the force acting on this one which is bringing it back to its original position. That is inversely. Okay, simple pendulum we have to. Okay, a simpler example would be a spring. Just a minute. For example, I take a spring. Spring is represented like this, right? Okay. And I attach a mass to this. So let me say this is the equilibrium position. So from here, if I stretch it downwards, okay, so the block comes here. So the force acting on this block, what is the upward force acting on this block?
Spring force.
No. So what is the expression? Initially, when it's at equilibrium, the weight and the upward extension, that will be x naught. So the upward force will be how much? K x naught, right? Okay. So mg equal to k x naught. And from this position, if I stretch it by an extra x, okay. So now the force acting on this mass is how much?
K x naught plus x.
Yeah. So k x naught plus x, and downward force will be mg. Okay. And from this initial position, we know that mg equal to k x naught. So mg and kx naught will cancel. There will be a net force of kx in the upward direction. Is that clear? Here initially, here's in equilibrium. So the force will be in balance.
Okay.
Okay. So
Okay.
this position, let me assume I stretch it and then left it. So when this is in stress position, it's still moving. So it has an acceleration, some acceleration. Okay. So the net force which is acting in the upward direction is kx, where x is the extension from the equilibrium position. Right, the total extension is x plus x naught. So the net force acting in the upward direction will be k into x plus x naught minus mg. And mg is kx naught. Is it clear?
Okay.
Okay. So the force
But
that is
MA equal to KX. That's what you're trying to say, right,
yeah,
sir?
that you'll get from the initial condition or the equilibrium condition. After that, I'm stretching it and leaving it. So when it's stretched by a position x, so the net force, upward force will be k into x plus x naught, that will be equal to, not equal to, the net upward force, this minus mg. Here this equilibrium equation will be equal because it's a rest position. After that, I'm stretching it and leaving it, so it's moving. So this will be equal to the F net. So that will be equal to mass and acceleration. Okay, so this acceleration in the upward direction, because I'm finding the net force in the upward direction. Okay, so this is the net force in the upward direction, right?
Yes, sir.
So that should be equal to mass and acceleration in the upward direction. So this is why I put the direction of E as upward. So from this Kx not an mg, from this first condition. Okay, so K into x equal to immediate. So this acceleration is Kx by m, where m is the mass of this block. So the acceleration is more if it is farther away from the equilibrium position. Okay, so as it approaches the equilibrium position, the acceleration is 0, but it will still go in the upward direction because it has acquired some velocity. So and as it moves away, the acceleration will be in the downward direction, and the value of the acceleration will be more and more as it goes away. And so somewhere the velocity will become 0. After the velocity becomes 0, it will turn back. Okay. So the difference between the thing thrown from the, say, Earth's surface, here also if you throw a ball, the velocity will keep on decreasing, right? After that, it will turn back. Yes or no?
Yes, sir. Yes, sir.
So similarly here also, when it goes up, the velocity will keep on decreasing and then it will turn back. What is the difference between this and this? It's an important difference. Where the force, it's reducing the velocity, that force is a constant force, the acceleration is constant or uniform, both. But here the acceleration is function of x, non-uniform.
Sir.
Okay, so this is the important new concept we are learning in this chapter. In the previous chapter, Newton's laws of motion, chapter 4, there and all its acceleration is constant or uniform. Both are true. Here, this is the first time we are coming across non-uniform acceleration. The acceleration is more as you go away from the equilibrium position. What about velocity? Velocity is less as you go away from the equilibrium position. Is that possible?
Sorry, what, sir? I didn't hear you.
Acceleration is more and more as you go away from the equilibrium position. Okay, but the velocity is less and less as you go away from the equilibrium position. Is that possible?
Sir.
What? What I'm saying is, as you go upwards from in the spring condition, spring case, acceleration is going up, right? But velocity is going down.
What do you say, sir?
What?
On what basis you are saying that when acceleration increases, velocity decreases, sir?
Actually, yeah, only then it will turn back, right?
Okay.
The reason why this is happening is
And
the direction of
sir,
acceleration.
acceleration increases in both cases, no, sir. When it goes upward and also when it goes downward, also that the acceleration increases, no?
Yeah,
X value increases.
Yeah, so the thing is, the direction of the acceleration is important. The direction of acceleration is towards the equilibrium position. The velocity is upwards. That's why velocity keeps on decreasing. So acceleration is not helping velocity. It's always opposing it.
Retardation. Okay.
Yeah. Here also, in this case of gravity, also acceleration is against velocity when it is going up. So that's why the velocity keeps on decreasing. But after it turns back, the acceleration is helping the velocity. The velocity will keep on increasing. But here, it's not like that. As you go up, the acceleration is towards the equilibrium position. So it is against the velocity. So when it comes back, again the acceleration is away. Sorry, when it's coming back, acceleration is towards the equilibrium position. So here it is helping the velocity. But after it crosses this point, acceleration is again against the velocity. When it comes back to the equilibrium position, acceleration is helping the velocity. What is
Yes, sir.
here are only two parts: going up part and then going down part. Going down part, the acceleration is helping the velocity. But here also, it's like going up and down only. So while going up, the acceleration is against the velocity. While coming up to the equilibrium position, it is with the velocity. So it is increasing the velocity. But once it crosses the equilibrium position, again it's again opposing the velocity. So it will keep on decreasing. And once it turns back up to the equilibrium position, it is helping the velocity. That's why it keeps on oscillating. What is
Okay.
velocity is
Yes, sir.
maximum at the mean position. It will keep on decreasing, but acceleration will keep on increasing. Okay, so
Okay.
acceleration is more against the velocity as you go away, more and more away from the equilibrium position. In the case of gravity, it's not the case. The accelerating or the retardation is constant. Okay, this is a new concept that we learn in this chapter. The acceleration is non-uniform. Acceleration is same as force, because force and acceleration relate force over mass and acceleration. It's just a scaling factor, mass. So acceleration is opposing velocity means actually force is opposing velocity.
Yes, sir.
So force is proportional to the distance from the mean position. That's what I said. Just k into x, and this minus sign, k is positive. So minus sign indicates the fact that the direction of the force or the direction of acceleration is opposite to the direction of x. Like while going up, acceleration is downwards, right? So x is positive, acceleration is negative. And while coming, even while coming, the x is still positive. But when it goes on the other side, x is negative, and force is in the positive direction. So here, this part, from here to here and here to here, x is positive and acceleration is negative. But in the downward part, this part, x is negative, but acceleration is in the positive direction, positive x. Right? The acceleration here and here are same. I think like this. The acceleration at this point, the acceleration at this point are same. The value is kx, and the direction is towards the equilibrium position. Okay.
Okay, it is symmetry.
Yeah, symmetry. And because the acceleration value is k into x, x is same for both because x is measured from the mean position. Okay. Similarly, the acceleration here and acceleration here is same. But what will be the acceleration if you compare these two? Which one is more?
Sorry, what, sir?
Acceleration here and here are same, right? What about acceleration? If you compare acceleration of this point, acceleration of this point, is it same or different or more? Which one is more?
Top most point will have more acceleration.
Which has got more acceleration? Which one?
Top most point will.
Yeah, because it's k into x.
That one.
So string when you stretch more, okay, so the force with which it can pull back is more. Okay, force more means acceleration is more. Got it? Okay, so that's what this negative sign indicates. In this upward part, so x is positive, right? But acceleration is downwards.
Yes, sir.
So in the downward part, x is negative, but force is in the positive direction. So and force is mass and acceleration, and how is acceleration related to x?
dv by dt. D square x by dt square.
Yeah.
Double.
This is a second order differential equation. So what is the solution of this equation? You know, right? It will be either sine or cos. If you take sine x or sine t, if you differentiate, what you will get?
Cos.
Cos. If you differentiate cos again, what you will get?
Sine. Sir.
So this statement means that when you take twice differential and when you take the original function, both should be same except for this factors, constant factors. Okay. So what is the function whose when I differentiate twice will give me the same function?
Yes, sir.
Sine and cos, right?
Yes.
If you take some other function log x, if you differentiate it twice, you will not get the original function. Log x, if you differentiate once, I'll get 1 by x. 1 by x, if I differentiate, I'll get x raised to the power -2, right?
But if you differentiate cos means minus sign, no, sir, you will get negative of the original function.
Yeah, that's why this minus sign is there.
Okay, okay.
But the first important thing is I have to take the function, differentiate it twice, I should get the same function back. That's what this means, right?
Yes.
Forget about the constants and all. Just the function form. D square by x with dt square should be same as the function. The function which has got the
Yes, sir.
property is sine or cos. So which function has the property? Suppose I say dx by dt equal to x. What is that function that will satisfy?
Cos of.
No, dx by dt equal to x. Not second derivative, first derivative.
Sorry, what's all right? Okay, quite error.
If we say dx by dt equal to x. So what is x? I have to find x. Let there be some constants here, k or whatever. Does not matter. So this is a. So what should be the form of x? So x as a function of t. So what is the function? If I differentiate it, I'll get the same function. Or I can just say dx by x equal to dt, right? And if I indicate both sides, I'll get ln x equal to t, right? So x equal to e raised to the power t. That's the basic function form. So is it true? We check from the origin.
Sir, yes, sir.
So the function and its derivative both are same functions. Forget about the constants. So that function is e raised to the power t.
Yes, sir.
We take a function, differentiate it twice, some variable, and that should be same as that function. So that function is sine
Sine or cos.
and that minus sign is taken care because if I differentiate sine once, either first step or second step, I'll get a negative. So when you have a function like this, where when you have an equation like this, the solution is either sine or cos. Okay, and integration constant will be there. So that constant is appearing as a angle constant. Okay, if you sine is differentiated like this, you get minus sine. If cos is differentiated twice, you get minus cos. So either cos or sine is the solution of this one. Okay, so if you say sine, then the constant will be different. If you say cos, the constant will be different. Here I put two same symbols, but it is different actually. Sine is same as cos except for a phase difference, right? Phase difference of pi by 2. Okay, so this is the plot of cos omega t plus phi. Here in this particular case, phi is how much? In this particular graph, what is the value of this initial phase? Phi. This is plot of cos, right? Yes or no? Understood the question?
What is phi, sir? Actually?
Yeah, so this is plot of cos, right?
Yes, sir.
So at time t equal to 0, this value is maximum. So it should be cos 0, right? At t equal to 0. So phi is 0.
Yes.
So for this actually plus of cos omega t. So it is omega t plus phi means it will be shifted left by phi. So t equal to 0, it takes an angle of phi. So here at t equal to some positive value, it takes an angle of phi. So it should be shifted left. So the displacement, maximum displacement amplitude of the SHM. So these are the different parts of this function. This amplitude, omega is the angular frequency, and this is called phase constant because it's not a dependent on time. It's independent of time. So time t equal to 0, whatever is the phase, that is the phase constant, or you can say initial phase. And cos function is periodic function, and what is the period of that? That periodicity is 2 pi, right? So cos of x plus t is equal to x of t. So this is the meaning of this period capital T. This is a periodic function with period capital. That means that x of t plus t is same as x of t. So from that, so suppose I use the same thing here for cos. Instead of t, if I put t plus capital T, I should get the same phase. So that means that omega into t should be 2 pi. Omega into capital T should be 2 pi. Right? Only then this thing will be periodic with capital T. This function is periodic capital T, t equal to capital T. That means that if I replace t by t plus capital T, then the phase should not change. That means that omega into capital T should be 2 pi. Is that clear?
No, I don't get it.
So this function is periodic with cos is periodic with what phase period?
I don't know.
Cos is periodic 2 pi, no? Cos sine.
Yes, sir. Period of sine and cos is 2 pi.
Yeah. So here we have cos of omega t plus phi, right?
Phi means initial angle, sir. Phi.
Whatever it is. Yeah, phi is the initial phase. So this thing is periodic with this thing being 2 pi, right? When the whole thing is changing by 2 pi, it will come back to this original thing. So this thing is, if this angle changes by 2 pi amount, then cos value is same. So when I put t equal to t plus t, the phase will change to this much, right? Yes or no? Suppose this is f of t. Okay, this is f of t plus t, right? Yes or no?
Yes, sir.
So periodic function, these two should be equal. That is possible if omega t equal to 2 pi. Or in general, you can say 2n pi, where n is an integer. Just consider the simplest case. So omega t should be 2 pi, right?
Yeah.
Okay, so that from that you will get t equal to 2 pi by omega. Or omega equal to 2 pi by capital T. So this is how you get this formula for the time period. And frequency is omega by 2 pi, reciprocal. So if you have one sine and one cos, you can combine them, right, mathematically as a single sine or cos. This you already know. Yes or no? These are simple mathematical tricks. You start studying maths itself. Your mic is off.
Can you please explain it, sir?
Which one? This one.
No, that a by root of a square plus b square sin omega t plus b by.
Yeah. See, here this is a single function, right?
Yes, sir.
Okay, now if you have two functions, one sine and one cos, I remove the phi, make it simple. So I can combine them and make it a single sine or cos. So to see that, the amplitude is different a and b. This thing I rewrite like this one.
No, I couldn't understand.
Just see it. You're just dividing by square root of a square plus b square, multiplying the root of a square plus b square. Right?
Can you please read that one? It's like a by a square plus b square sin omega t plus b by am I right, sir? Into
This is a mathematical step from here to here. What is the problem?
I don't know what they have done in this equation.
No, from here to here, you just have to divide by square root of a square plus b square and then multiply by square root of a square. You just take this inside, you get the same thing, right?
But they have, but here the equation sin omega t is in denominator.
Which denominator? No. It's just into. It's not in the denominator. You can understand from here to here, right? But you have to just blindly read this one.
Okay. If sin term, then
then you have to. Then we can construct a right angle triangle with sides A, B, and C. Where C is the hypotenuse, or A, B, and hypotenuse is square root of a square plus b square.
okay.
So from that you can. So now we can construct a triangle like this. Right angle triangle. So A, B, and this is square root of a square plus b square. So okay, this is sine, right? So I'll make this as sine. So I'll take this angle as minus phi. Sine phi is A divided by root, right? This thing is sine phi. And what is this thing? Cos phi, right?
Yes, sir.
Okay. So now I can combine this one as sine omega t plus phi.
Huh? That is sin phi plus cos phi only, no, sir.
No, sine A plus B formula.
Sin A plus B is equal to sin A cos B minus cos A sin B. That's the
Okay.
formula.
Right. Okay, then this should be fine. This angle is phi. So this will become cos phi. And this is sin phi. Okay, combined will become omega t plus phi. So that's why we written here. Phi is tan B by E. So tan inverse B by E.
Oh, how have you that simplified it into cos phi plus sin phi? How does it become equal to sin omega t plus phi, sir?
So this is cos. What is this is sin omega t cos phi, right? Plus cos omega t sin phi. Sin A plus B. This difference is from this sin A cos B plus cos A sin B, right?
Okay. Okay. Sin A plus B. All right.
This thing will become sin omega t plus phi.
Yes, sir. Got it.
The important thing here is phi is not a function of time. Why is it not a function of time? Because A is not a function of time, B is not a function of time. So this triangle is not a function of time. So this angle is not a function of time. So here everything is constant. Because AB and AB are constant, right? From this step. Only the time variable is
Sure.
A and B are constant, so phi is also constant. Okay, so it becomes a phase constant. This thing can be written as, if you go to D, but D is square root of A square plus B square, which is the constant. So the important thing is sum of sine and cos is combined as a single sine function with a phase. Okay, so this we can think as two SHMs. If I combine them, it will become a single SHM. These are two SHMs. I can, the resultant will be a single SHM. Like if you have two forces, I can combine them and make a resultant force, right?
Yes, sir.
Similar to two SHMs means will combine and become a single SHM.
And what is the phi, sir? Phi value?
Once you go A and B, phi is fixed. A and B is fixed means the triangle is
Okay.
fixed, right? If the triangle is fixed,
Okay.
be tan inverse B by E.
Okay. Phi is the angle between A and B.
No, phi is just a constant. It doesn't have a meaning. It just depends on B and A. Okay.
Yes, sir.
So uniform circular motion means the thing is moving like this in two dimensions, x and y. So the thing will move like this in a uniform circular motion. This is a periodic motion, right? Periodic in the sense it's coming back to the same position again and again. So, but if this periodic motion, if you see from this side and concentrate just on this y motion, the y motion is also periodic because y is 0 here, maximum.
So it's periodic motion, and does its force proportional to x, sir?
It can be. Periodic motion is more general. In that, one category is forces x. Okay, periodic motion is just
Force, then which force is acting and said that is proportional to that displacement. There are only two forces, no centripetal and mg.
no. Don't jump too much. Just as I said, this is just a uniform regulation, imaginary motion. It's not actual motion. Okay, but suppose there is some uniform circle. This is sun. This is Earth. Earth is moving around the sun, right? Okay,
Okay.
that's a periodic motion. But suppose if I draw this y-axis and just look at the y motion, not the x motion. So y motion is also periodic. The full motion is periodic circular motion. But if you just look at the y motion, y is 0 here, keeps on increasing, becomes maximum, then decreasing. After that, y becomes negative, keeps on increasing in the negative direction, and then turns back, and then it comes back here. This motion is also periodic, which is concentrated on the y part. Okay.
It is periodic, sir, but on what basis you can say it as a SHM? There is no evidence that force.
Not come to that. Okay, so
Okay.
this motion is rate at which the y is changing. Here we know how here instead of x I can put y also. So x is changing like y is changing like cos, right? So similarly, this y motion also changes like either sine or cos things in SHM. Okay, so this y motion, it's in terms of this radius vector, we can write as suppose this radius of the circle is r, then y is r sine omega t plus phi, right? Radius is fixed, let the radius be r. So y is r sine omega t plus phi. So that means y is changing as sine of omega t plus phi. That's an SHM. SHM is same as saying the motion is sine or cos. Because once you say SHM, this equation is valid. Okay, once this equation is valid, then the motion is either sine or cos. Here we have steadily got the y motion is sine omega t plus phi. So it's SHM.
So how did you come that R is equal to sine omega t plus 5 second? Please explain.
From the triangle, right angle triangle. This is a right angle triangle, right? This is R. This is the angle. So what is the vertical distance? Y, right?
Okay.
Y is sine R sine omega t plus 5. Whatever is this angle. Okay.
Sine omega t plus 5 is y by a, no sir.
No. This angle is omega t plus 5. Okay. In this particular case, 5 might be 0, but in general, it will be omega t plus 5. So what is this angle? If we take sine of that angle, I'll get y divided by r. So from that, y is r sine this angle.
Okay.
Okay. So this
Here
y,
that r is a amplitude. Okay.
yeah.
Okay.
So this y motion is a sinusoidal motion, so it's a SHM motion. So if you have a uniform circular motion, we take this constant on this y part of the motion. Y motion is a SHM. Similarly, x motion is also SHM because x is r sine or cos omega t plus 5. Okay. Yeah, so displacement, here it is x is maximum at t equal to 0. Okay, so and it keeps on decreasing. So it starts from the far away from the equilibrium position. So it moves towards the equilibrium position, the displacement becomes 0. And after that, it moves on the other side, negative, and then becomes negative on the maximum side. After that, it turn back, and it'll come here. Okay. So this thing, if we think in terms of spring motion, what is the initial? So the initial position of the spring is stretch position.
Equilibrium position.
Equilibrium position is x equals 0. So here x is maximum. So time t equal to 0. The situation is like it's on the positive side, right? So okay, I can define positive either way also. It's like this being stretched here. This is the positive x direction. I'm taking the downward direction as positive x. That's why it's become z t equal to 0. So at t equal to some later time, so this is t equal to 0. So as time increases, it will move up. Okay, so the amount of x is decreasing. So that's what is happening here. X is decreasing, and at some stage, and reach the equilibrium position. That is at this time, everything is 0. After that, x becomes negative because I'm taking the positive direction as downward. Okay, so is this clear? Displacement will go like this, and the velocity will be like this. Velocity at the extreme position will be 0. Okay, after that, it will keep on increasing in this direction. The velocity at this point is upwards. So it's opposite to the positive direction I've taken here. So its velocity is negative. Okay, once it reaches this position, still it's negative, going up only, and it will continue to go up until it turns back. So it continues to remain negative. So this is a turning back point. Okay, after that it's moving downwards. So velocity has become positive, but the x has become positive here itself. Got it? X has become positive, but velocity is still negative. Because this point is corresponding to this point. Sorry, here. Here. What is it? X. So here, at this point, the velocity is negative, and it's still going to continue negative up to this point. But excess is negative up to this point only. After x will become positive. Okay, x has become negative from here because I'm taking the direction as positive. Okay, so the x changing of positive has happened here, but velocity changing from positive to negative has not happened. It happened at the turn. So there is a phase difference between x and y, and that phase difference is 90 degrees.
Yes, sir.
Okay, so next you can think of acceleration. Acceleration is same as x, but for the negative sign. So whenever x is positive, acceleration will be negative, and whenever x is negative, the acceleration will be positive. But x is negative from here to here, so it's positive from here to here. Okay, so the phase difference between displacement and acceleration is 180 degrees. So the negative sign is that. Minus 1 is same as the phase difference of 180 degrees. Okay. So is this clear? The variation of displacement, velocity, and acceleration. Okay. So this is way of understanding this. Another thing is taking the derivative. The derivative here is negative. So it's negative. From here, the derivative. Sorry, derivative here is negative. Here also derivative is negative. From here, the derivative becomes positive. So from here, it's positive. And if you differentiate this thing again, here the derivative is negative. From here, the derivative becomes positive up to here. So it's positive up from here to here. Is it clear? That is another way of understanding. Okay, so this is one formula that you can remember. K equal to m omega square, you have to remember. This you can remember, right? One way to remember.
Sir. Let me see one second.
Omega is the frequency, and you relate to K and M. In the case of spring motion, K is the spring constant, and M is the mass of the block. So this one way of remembering this formula is.
Okay, we have to double differentiate that one. Okay, fine, sir.
No, that is a derivation, but how to remember this formula? One way to remember is kinetic is half mv square, right? So this is similar to that. K is half omega. Half is not there. M omega square. Okay. From there I can get this formula also. Period is 2 pi by omega, right? Or omega by 2 pi. 2 pi by omega. And from there also I can get this thing. Or you can remember this formula also. T equal to 2 pi into square root of n by k.
Yeah. Wait, sir, I will put my Bluetooth to charge. Charge. 1 minute, sir. Sir?
So the time period t is 2 pi by omega, right?
Yes, sir.
Distance by velocity. Distance is angular distance 2 pi for one rotation, and speed is omega. So from there we get the capital T as 2 pi by omega. Using that thing, you can get this formula also.
Yes, sir.
If you're finding it difficult to remember both, just remember this one, and then capital T is 2 pi by omega. Omega is square root of m by k. Omega is square root of k by m. So from there you get this formula. And kinetic energy is half m v square, where v is the velocity. And velocity expression you know, because x is known. If you take and differentiate, do dx by dt, I'll get this one. So kinetic energy is half k, this one. So these are all basics. So and potential energy is half k x square. Potential energy of a spring. So from that, and x is known. So from there, I'll get the variation of this one. And total energy is k plus u. So if you add this one and this one, it's constant. Okay. So the variation of kinetic energy will be this blue curve. Okay. And this is actually sine square. So sine square cos square will have period of pi. Sine and cos will have a period of 2 pi, and sine square and cos will have a period of pi. Okay. So and the total energy is constant. So both these things are in opposite way. So when one is decreasing, the other one is increasing. Kinetic energy is increasing, but the potential energy is decreasing, but the total of them is constant. This is just one single period from here to here. Okay. So, right. If you take a simple pendulum, is it an SHM?
Yes, sir.
Okay. It's under one particular condition. This angle theta should not be large, it should be small. Okay, because it's a condition that the restoring force, to prove that it's a simple harmonic motion, you have to prove that the restoring force or restoring torque, whatever is the case, should be proportional to the displacement. So when you're doing this thing, here the restoring torque is mg sin theta into a, because mg is the force which will bring it back, but the component that will bring it back is mg cos theta is mg sin. This angle is theta, right? So this angle is theta. So mg cos theta is this one, and mg sin theta, this is the force that will bring it back. So and this torque is mg sin theta and the resistance L. So this is the restoring torque. Okay, in terms of linear motion, it's restoring force. Here it's an angular motion. Okay, so the instead of force, you talk about torque. So restoring torque is this one. Is this clear? There is no other force acting on this one. Tension is there, but it will not produce any torque because it's passing through the origin. Torque is R cross F, right? So if R is 0,
Yes, sir. Yes.
torque won't be there. So torque is produced only by this weight component in this direction. So this is the restoring torque. This is clear. Okay. So and restoring torque is I into alpha, like force is mass into acceleration. Torque is instead of mass we have I moment of inertia into acceleration alpha. And if you use the and sine theta, this is expansion for small angle theta, sine theta is approximately theta. So when you do this approximation, it comes out that the restoring torque is proportional to the displacement. So only under this condition, this is simple harmonic motion. So for the thing to behave like a simple harmonic motion, the conditions are small oscillations. So you get the same equation, where the second derivative of the function is same as a function. So theta should be a cos or a sine. We're taking cos. Okay. So the time period. So from this we can get omega as this one. Okay. So from there we get the time period T as 2 pi square root of L by G, where capital L is what?
Length of the pendulum.
Yeah, G is gravity. Waves. Okay, this is 2021. Try this question.
I don't know, sir. I can't relate potential energy with frequency.
Write the expression for potential energy. You'll understand. What is the simple harmonization of the frequency and the frequency of potential energy is? This is a trivial question. Actually, you should straight away take it because it's like a theoretical question. That's what I said here, right? So potential energy is cos square. Okay. So the frequency, the time periodicity of this one compared to the motion is displacement is cos or sine, right? And potential energy is cos square. So if cos has got a displacement got a frequency, if potential will have a frequency 2f. Is it clear? Cos will have say periodicity t. Cos will have a periodicity t by 2. Yes or no?
Wait a minute, sir.
This is cos, right? So suppose we plot for cos square, the root is 0, it will be 0. Okay.
5 by 2 and 5 extra 5.
Here, periodicity is.
Yes, sir.
Here if you have,
Period of cos square is 5.
this is a variation of cos. The periodicity is this one, right? The full thing. Only after that is repeating. Okay.
Yes, sir.
Cos square will look this. For cos square, this itself is repeating.
Yes, sir.
Okay. So in general, cos square periodicity will be half. So frequency will be double. Because
2 times.
yeah. So answer is 2. Okay, here is that potential energy. What about kinetic energy?
Kinetic energy expression sign also.
Sine or cos does not matter. It's half k, half m v square, right? And v is if x was cos, v will be sine square. See,
Again, it's 2 times n, sir.
yeah. And it has to, because it has to match the variation of potential energy so that the sum will be always constant, right? If kinetic energy, potential energy is changing with the frequency of twice, kinetic energy should also change the same frequency so that the sum is same, right? If one of them is changing with different frequency, then you cannot add them up to get the constant. Because when one is become positive maximum, the other should become minimum. When it's decreasing, it should decrease. When they are both average, actually there is no negative here. It's always positive. When both are average value, it's both are average, and one is increasing, one is decreasing. So the frequency with which it's changing should be same for both. Or you can just straight away look from the expression half k, half m v square, and so sine will have some frequency, then sine square and cos will have a double frequency. Right? Instead of sine t, consider sine square t and cos square t. Sine t has got frequency f, sine square t and cos t will have frequency 2f. Yes? This is actually sine square t, blue one. And this is cos square t. Because t equal to 0, sine square t will be 0, and cos square t will have a maximum. So this is sine square t, and this is cos square t. And both of them will have the same frequency, double that of the original function. Is it clear? Done? Identify the function. Okay, this is the NCRT question. Give it from NCRT.
Periodic motion sine omega t plus cos omega. See, sir.
I know it. This is definitely periodic because even if you have two periodic functions and add them up, it will still be periodic. Phase difference between
Pi red. They're exactly opposite in that graph. So we're 180-degree difference.
yeah 180 degrees. So d pi radius. So this was a theoretical question. Distance covered by a particle under the system in one time period. This was a trivial question.
One time period. Distance, all right. A, 2A, 4A.
Yeah, 4D. What about displacement?
0.
Yeah, because it's coming back to the same question. Displacement is how far is the initial and final points are. Distance is actually the path length. Okay, so if we just roam around and come back to the same point, displacement is 0, but distance is that's a path length. It won't be, it need not be 0. Okay, average velocity for particle executing the system in one complete vibration. This is also a trivial question.
Average means we have to take integral of them and divide it by integral of the time period as well.
But it's a common sense based question. If things are equally positive and negative, average will be 0, right?
Yes, sir.
So velocity in one part of the motion it's positive, other part of the motion it's negative, equally positive and equally negative. You can figure out that.
Then it will be 0.
Yeah, it will be 0. So just in the case of a ball thrown from the earth, while going up the velocity is positive if I take the upward direction is positive, and while going down in the same symmetric point it is downwards, same negative value, right? Okay.
Then tell me the general procedure to find the average of one function, sir.
Yeah, average of function integral f dt divided by integral dt.
Integral of that function by integral of the time period. Am I right, sir?
And let me write it. If you want the time average of a function, I have to integral f dt divided by integral dt over the time period. Okay, and the denominator is capital T. So this integral for a sin omega t plus phi dt is 0.
0.
Sin omega t, right? If you integrate, you get cos, and cos at 0 and cos at capital T will be same. Cos at 0 and cos at 2 pi are same, right?
But minus no, sir.
Yeah, all those things you can take it. If you just look at the,
Minus.
if you just look at the function value, okay, it's coming back to the same point. Okay, after a time period. So the value of cos at the initial time and after completed time period will be same. So it gets subtracted and becomes 0.
Okay, okay.
The displacement of a particle visible in SHM is given by this one. The amplitude of the oscillation is okay. This this is also a simple mathematical question, and
Yes, sir.
you just have to work out but just one step. Suppose this A naught is not there, then what is the amplitude of oscillation? Suppose this A naught.
Same root of a square plus b square only, sir.
Yeah. So this thing is shifting the whole thing upwards. Let's just say A naught is positive. Okay.
We're just adding one constant.
Suppose if this thing is varying like this, when you add A naught, the variation will happen at higher pace. Amplitude is a displacement maximum point. So the displacement will become maximum displacement will become A naught plus this one. Okay, so it should be option D. Suppose I consider amplitude as a maximum positive displacement, but suppose I think amplitude as a displacement in the mean position, then the amplitude will not change. But that is not the way of defining amplitude. Amplitude is the maximum positive displacement. So correct option should be option D. Option A. Okay, that's all. It depends on how we define the amplitude. Amplitude is the maximum displacement from the mean position. Okay, so it's option A1. So amplitude is not from x equal to 0. Amplitude is measured from the mean position. Okay, which is still square root of a square plus b square. Because this thing is just lifting the variation to a higher level. Okay, but the amount of variation is still same. It is happening at a higher level. That's all. So amplitude is just measure of how much it's vibrating.
Yeah.
Okay, so you should know what amplitude means or the definition of amplitude. Amplitude is a maximum variation from the mean position. Okay, whether I'm varying here or varying at a height, what matters is how much I'm varying. The correct option is option A. Displacement of a particle is given as this one in general. Okay. 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 Yes. Should we assume? Right. Radius of a circle, the time period of revolution, sense of revolution is indicated. Y projection of the radius vector is. Okay. This is a simple mathematical question. (2019). Okay, with this answer. Is it a trivial question? Amplitude values are given, so just have to use them. And time t equal to 0. Okay, so put it properly. Open the point P. This point. This is the point P. So initially it is here. So what is the amplitude of the oscillation?
3.
Yeah, so you can say remove this option. And the y is
Pi
max
by
equal to 0, right?
3 cos pi by 2 t. Okay. Option C, sir.
Okay,
Third option.
what is the question? The y projection.
Huh?
What is the question? Radius of a circle, time period, initial question.
Sorry, what, sir? I didn't.
What is the question? Y projection of the radius vector of rotating.
Y projection of the radius vector of is
Okay,
not
it's
displacement.
omega, right? This is sine.
Here its phase is 0 only, no, sir. Phase constant value.
Yeah, because we have taken cos. Okay, and it's cos omega t. So what is omega? Omega is 2 pi
2 pi by t.
And it's 2 pi
Pi by 2.
So pi by 2 omega. Omega t, right?
Oh, yes, sir.
Option C. Close now. We'll close now.
Okay, sir, fine.
Tomorrow we'll meet at 3:30.
Sorry, what?
Tomorrow we'll have class at 3:30.
No, sir. I can laptop. I'll get my laptop after 7 only.
Okay. Right. But soon I'll be shifting 3:30 only. But over 11:30 in the morning.
No, before 10, sir. Before 9:30. Sure. Are you free?
No, I don't know. Okay, we'll meet at 7:30 only.
Okay, sir.